Students, in this video, I am going to explain you about chapter probability questions from 2023 CBSE board exam. Clear? So here the question is from case study, students. So case study question. Okay. So I think you can read this question. Here they have given 1,000 elementary and secondary schools of Assam. A survey has done, means how many schools are having number of computers in their computer lab. Okay. Here try to understand the tabular column, students. The number of computers are from 1 to 10, that is 250 number of schools are having, and 200 number of schools are having 11 to 20, and 290 number of schools are having 21 to 50 computers, and 180 number of schools are having 51 to 100 computers, and 80 schools are having 101 and more number of computers. This is about this tabular column. Let us answer these questions given. Okay. So the first one is find the probability that the school chosen at random has more than 100 computers. So where is more than 100 computers? This one, right? So how many are there? That is number of schools is 80 out of how many schools? Out of 1,000 schools. So converting this into simplest form gives our answer. So afterwards I will explain how to present our answer in your examination. Clear? So the second bit internal choice is there. So A bit both the answers we will see. Find the probability that the school chosen at random has 50 or fewer computers. What do you mean by 50 or fewer? Means 50 and less than 50. Okay. 50 or less than 50. Clear? Okay, students. So 50 and less than 50. How many are there? So 250, 200, 290. Clear? So these three you have to add and divide by total number of schools. Okay. Next, find the probability that the school chosen at random has not more than 20 computers. Which school is having not more than 20 computers? So no more than 20 computers means 1 to 10 and 11 to 20. Clear? Next, this one 1 to 10 and 11 to 20. This is 250 and 200. Okay. Next, find the probability that the school chosen at random has 10 or less than 10 computers. 10 and less than means only we will get 1 to 10, that is 250. Clear, students? Now we are going to see how to present our answers. So let us see what is the number of possible outcomes. Okay, let us write number of possible outcomes. Okay. So how many are there? 80 schools are having the required number of computers, more than 100 computers. Okay. Schools is how many? 1,000 schools are there. Okay. Next. Now let us find out the probability. So first we have to write the probability of an event is given as number of outcomes. We have to write the formula, students. Number of outcomes by total number of outcomes. Okay. Okay. So what is the number of outcomes here? 80 and divided by how much? Total is 1,000. So convert into simplest form, students. You will get the answer as 2 by 25. Did you understand how to present? Okay. Let us see the second bit, both the answers. Okay. So second one, what they are asking? 50 or fewer number of computers. Okay, 50 or fewer number of computers means 50 and less than 50. That is 250, 200 and 290. Clear? So the second one we are having A bit. So in A bit, number of possible outcomes. Okay. Is equal to, so we have to add 250, 200 and 290. number of schools. So after adding, how much you will get? Okay, 0 here, 4 here, 7 here. Okay, 740. And we know the total number of schools, that is 1000. Okay, so let us write the formula P of event. Okay, P of event, E is equal to number of outcomes, possible outcomes. The possible outcomes we got as 740. Okay, by total number of outcomes. Okay, students. So each and every time you have to write the formula, don't forget to write, then only you will get the full marks. Okay, 740 divided by 1000. Now convert this into your simplest form, you will get 37 divided by 50. Okay, this is our answer. And second bit, option B. Okay, find the probability that the school chosen at random has not more than 20 computers. So what is the number of possible outcomes here, students? So number of possible outcomes. Okay, so how many are there? How many schools are there? That is 250 and 200. You add these two. Okay, 450 schools. Clear? So what is the formula? P of event is equal to number of outcomes by total number of outcomes. Okay. So 450 and the total number is 1000. So just convert into its simplest form, students. You will get the answer as 9 by 20. Did you understand, students? Okay. So the next, so third bit, what they are asking, the question is find the probability that the school chosen at random has 10 or less than 10 computers. Means 1 to 10 interval. Okay. So 1 to 10 number of computers. How many schools are having? 250 schools are having. Write down number of possible outcomes. Okay. Is equal to how many? So only 250. Now probability of an event of this particular event. Okay. Is equal to how many you got? You have to write the formula and then solve this. Okay. I am doing directly 250 by 1000. So convert into simplest form, students. You will get 1 by 4. Okay. 250 into 4 gives 1000, isn't it? So did you understand, students, how to answer the case study sums? Clear? The next question is, in a family of 2 children, the probability of having at least one girl. Suppose we are having 2 children, students. So how many chances can be there? Let us write the total number of chances. Okay. Total number of outcomes we'll write. Okay. How many outcomes we'll have? That is, they may have one boy and one girl. Okay. Or they may have 2 boys. Or they may have 2 girls. Or they may have a girl and a boy. Right. So total how many chances are there? So 4 chances are there. Now they are asking us at least one goal. So number of possible outcomes. Okay. So number of possible outcomes. How many students? At least one girl means here one girl is there. Here one girl, here also one girl is there. So how many chances are there? So 3 chances are there. Right. So probability of this event will be, write the formula. Okay. Number of possible outcomes whole divided by total number of outcomes. This is the simple way of writing the formula I am explaining. Clear? You can write as they have given in your textbook also. Okay. So 3 by 4 will be our answer. Okay. If you want to convert into its decimal form, you can do. Okay. Did you understand, students? Students, the next question is, a bag contains 100 cards. How many are there? 100 cards are there and they are numbered from 1 to 100. Okay. So total number of cards or total number of outcomes. How many are there, students? That is equal to 100. Clear? Now they are asking us to draw a card. A card is drawn randomly from the bag. So the probability of getting a perfect cube they are asking, students. So let us write the total number of outcomes, how many we will get. Okay. So what we have to do? We have to write the perfect cubes from 1 to 100. So 1 cube gives 1, 2 cube, 3 cube, 4 cube, 5 cube gives 125. So we cannot write. So what are the answers? 1, comma 8, comma 27, comma 64. Right. So how many we got, students? 4. Okay. So 5 cube gives how much? 125. That is greater than 100. So 4 are there. Let us write the probability of this event gives how much? So 4 divided by 100. The answer is 1 by 25. Did you understand, students? Students, the next question is, a number is chosen from the numbers 1, 2, 3 and denoted as x, okay? And 1, 4, 9 and denoted as y, okay? So from the given numbers, then p of, what they are asking? P of x, y should be less than 9 they are asking. This is the probability they are asking, okay? Means the product should be less than 9. So what are the, see xy means what is the possibility here? Let us check all the possibilities. Okay, total possible outcomes. Okay, total possible outcomes. Let us write all the outcomes what are there here. Okay. So here first 1, 2, 3 is there. What are the chances to get first one with the next one? Next one with 4. Next one with 9. Clear? And again take 2 with 1. And 2 with 4 and 2 with 9. Okay. So next 3 with 1, 3 with 4 and 3 with 9. So how many possibilities are there? Total possibilities, students. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9 are there. Now let us check the product. Should be less than 9. Okay. So number of possible outcomes. What are they? Okay. So let us write. So 1 into 1 gives 1 only. We can take this. This is less than 1. 1 into 4 gives 4. And this is less than 9. Okay. Next 1 into 9 gives 9. We cannot take that. Next 2 comma 1 gives 2 ones are 2. Okay. Next 2 comma 4 gives 8. Okay. This is less than and we can take, and 2 and 9. 2 nines are 18. We cannot take that. Next 3 comma 1 gives 3 only. So we can take this. And 3 comma 4 gives 12 and 3 comma 9 gives 18. So we cannot take those combinations. So how many we got here? 1, 2, 3, 4, 5. So possible outcomes we got 5, students. Now what is the probability? P of an event E will be equal to, so number of possible outcomes is 5 and total number of outcomes is 9. So this is our probability. Did you understand, students? Students, the next question is, in a single throw of 2 dice, means here they are throwing 2 dice and they are asking the probability of getting a sum of 10. Okay. So before solving this question, you have to know what are the chances, what are the total possible chances if we throw 2 dice. That one I am going to write here. Okay. Okay, students, these are the chances if we throw 2 dice at a time. Clear? So here they are asking a sum of 10. Okay. So let us write total possible outcomes. Okay. Total possible outcomes. So count all these. How many students? Count all this. This side 6 and this side 6. 6 into 6 matrix, that is 36. Right. So number of possible outcomes. Okay. Let us write the number of possible outcomes, students. So what are the possible outcomes to get sum 10? Okay. So for the first row not there, second row, no, third row, fifth row, yes, 5 comma 5 gives 10, okay. 4 comma 6 gives 10, okay. And 6 comma 4 gives 10. Clear? Did you understand, students? So how many chances are there? Here you write the possible outcomes. So 4 comma 6 and 5 comma 5 and 6 comma 4. Clear? So total how many are there? That is 3. Okay. So write the probability of an event now. So find out the probability. Write the formula. Okay. You have to write the formula, students. So number of possible outcomes by total number of outcomes. Okay. So what is the answer, students? So how many 3 possibilities are there out of 36? So the probability is 1 by 12. Did you understand, students? Students, the next question is, in a single throw of 2 dice, the probability of getting 12 as a product. Okay. So what are the possible total number of outcomes? Okay. Total possible outcomes. Okay. How many for 2 dice? Just now we have seen that is 36. Right. So getting a 12 as a product. Let us see here. These are the chances. Product means multiply 2 numbers so that you will get 12. So what are the chances here, students? So here we have 4 3s are 12. Okay. This one, 3 4s are 12. Next, 4 3s are 12. Okay. Next, 6 2s are 12. Okay. Next, 2 6 are 12. Is there any other chance, students? Please check and tell. Out of these chances, how many we got? We got 4. So let us write all the possibilities in our question. Okay. So total number of possible outcomes. Okay. So number of possible outcomes, right? So let us write the number of possible outcomes. That is 2 comma 6. Okay. 3 comma 4. 4 comma 3 and 6 comma 2. So how many are there? 1, 2, 3, 4. 4 are there. Now let us write the probability. Probability of an event, you have to write the formula first and then write that is, sorry. So probability of an event P of E is equal to, so you have to write the formula first and then write the answer, that is number of possible outcomes is 4, then total number of outcomes is 36. 4 by 36 is our answer. So 1 by 9. Okay. Did you understand, students? Students, the next two questions are from assertion and reasoning. Clear? So let us see the first one. A fair die is thrown once. So the die is thrown once. The probability of getting a prime number is 1 by 2 they are asking. Okay. So before going into solving, let us write the chances if we throw a single die. Okay. If we throw a single die, what are the chances, students? 1, 2, 3, 4, 5, 6. Clear? So getting a prime number, how many prime numbers are there? 2, 3 and 5. Total 3 prime numbers are there. So So number of outcomes is 3 and total number of outcomes is 6. Okay. So 3 by 6, that is equal to, if you convert this into simplest form, you will get 1 by 2. Yes, this assertion A is true. Right. Let us see the reason. The reason is a natural number is a prime number if it has only two factors. So what is the definition for a prime number? A prime number is having only two factors, 1 and the number itself. Clear? 1 and number itself. Okay. So what you are going to say, is the reason true? Yes, this is also true. Clear? Next. So next assertion. Okay. Next question, assertion. Students, two players Sania and Ashnam play a tennis match. The probability of Sania winning the match is 0.79. So here P of E they have given 0.79 and that of Ashnam winning the match is 0.21. So let us check. So P of not E, they have given 0.21. Okay. So if we add, we must get the answer as 1 student. So let us check here. 10, 10, 1. So we got the answer as 1. Is this true or false? Yes, here the assertion is true. Next, the reason. The sum of probabilities of two complementary events is 1. Yes, if we add two complementary events, we will get the reason. You will get the answer as 1. So, this reason is also true. Did you understand, students? In a lottery, there are 5 prizes and 20 blanks. Okay. So, the probability of getting a prize they are asking. Okay. So, total how many are there? So, total number of outcomes we will write. Okay. So, total number of outcomes is equal to how many? 5 prizes and 20 blanks. The total we got as 25. Okay. So now the number of outcomes of for getting a prize. Okay. A prize. A prize means only single prize, but we are having 5 prizes here. So we are having 5 chances. Okay. So what is the probability of the event? Event I am going to take in a capital letter E. So the formula is number of outcomes, number of possible outcomes. Okay. By total number of outcomes. Okay, students. So how many are there? Just apply the values. 5 by 25. The answer is 1 by 5. Clear? Did you understand, students?